Students, we will continue chapter 2 of physics, that was force and pressure, motion. The topic I'll be starting today is scalar and vector quantity. You have already studied what is a physical quantity. Any quantity that can be measured is known as a physical quantity. Now, physical quantity is of two types, scalar quantity and vector quantity. Now, we'll learn what are these. A quantity which can be represented with magnitude only. What do you mean by magnitude? Magnitude means numerical value and the unit. Like when you tell about length of any object, you just say that the length of the object is 5 meter or 7 meter or 2 centimeter. You are specifying the value, that is 5, and the unit, that is meter. So this is known as magnitude, numerical value and unit. A quantity which needs only magnitude for their description is known as scalar quantity. Other examples are time, speed, and one is length. Scalar quantities do not need direction for their representation. You don't never mention the direction in which direction you are measuring the length. So this is scalar quantity. Next type of physical quantity is vector quantity. The quantity which need both magnitude and direction for representation is called a vector quantity. They need magnitude as well as direction. For example, weight, velocity, force. Weight of a body always act in downward direction. So direction is mentioned along with this quantity, so it is known as vector quantity. Scalar quantity needs only magnitude and vector quantity needs magnitude as well as direction. We will learn now two physical quantities, distance and displacement. The first is distance. What is distance? The actual length of the path covered by a body is called distance. When a body is moving from one point to another, then the length of that path which the body is covering is known as distance. Distance does not depend on direction. Distance of a body does not depend on direction. In whatever direction you move, it doesn't matter. You will only say that the distance we have covered is 50 meters or 100 meter, whatever it is, without mentioning the direction. The SI unit of distance is meter, denoted by small m. The next new term that you will be learning now is displacement. The shortest possible distance covered by a body between its initial, means starting position, and final position is called displacement. Shortest possible distance from starting to final is displacement. It is always a straight line path. It is essential to state the direction of motion for displacement. Displacement is a vector quantity and is represented with the help of direction. The SI unit of displacement is meter. Distance is a scalar quantity. It does not depend on direction, whereas displacement, which depends on direction, is a vector quantity. Distance and displacement concept will be clear to you with the help of this figure. Look at the given figure. A is the initial or the starting point and B is the final position. We have to move from A to B. Now there are two paths in the given figure. This is path 1, which is a curved path, and this is path 2, which is a straight line path. We can choose any one of the two paths to move from A to B. Now if I choose path A, when we are moving from A to B, the distance covered is 40 meter as mentioned here, and when we move along this straight line path, that is this one, the distance covered is 30 meter. Now if we choose first path, the distance is equal to 40 meter because this is the actual length of the path which we have taken. So distance is 40 meter, but displacement will be 30 meter because between the initial and the final position, the shortest distance is 30 meter, which is a straight line path. So if I take first path, displacement is 30, but distance is 40. Actual length is 40 meter, that is distance, and shortest length is 30 meter, which is displacement. Now look at second path. If we take second path, then displacement is 30 meter. Also, because we are moving along this straight line path, shortest path only, distance will also be 30 meters. So actual length and displacement remain same when we take the second path. This is the distance difference between distance and displacement. Displacement represents the shortest path and distance represents the actual length of the path which we have taken. Next physical quantity that we'll be learning is speed. Speed of an object is the distance traveled by it in unit time. If an object is covering 10 meters in 1 second, then the speed of the object will be 10 meter per second in one time. Unit time means 1 second or 1 hour or 1 minute depending upon which unit we are taking. That unit means one time. How much distance the body is covering is known as its speed. The formula for calculating speed is distance traveled upon time taken. Speed is equal to distance upon time. What are the units of speed? Anything that can be measured has a unit. Units of speed in SI system, SI unit of speed is meter per second because speed was distance upon time. SI unit of distance is meter, SI unit of time is second. So SI unit of speed is meter per second. Small values of speed are expressed in centimeter per second. Centimeter per second. And large speed values are expressed in kilometers per hour. We have already learned classification of motion before. Now, depending on the nature of speed of the moving object, with what speed the object is moving, there is one more classification of motion. There are two types of motion depending on nature of speed. They are uniform motion and non-uniform motion. What is a uniform motion? When an object which is moving on a straight line path is moving with constant speed, that is the speed of an object is not changing, then that object is said to have uniform motion. The speed of the object does not change. If the object is initially moving at 15 meter per second, then it will continue to move with the same speed. The speed of the body will not change. This is known as uniform motion. And because the speed of the object is not changing, the object will cover equal distance in equal time. So for example, if the object was covering 10 meter in 5 seconds, then the object will cover next 10 meters also in 5 seconds. The speed is constant, so the distance covered will be equal in equal interval of time. The distance will be same. If 10 meters is covered in 5 seconds, next 10 meter will also be covered in 5 seconds. Example of uniform motion is motion of a car running at a constant speed. When the car is running on a straight road and the speed of the car is not changing, then it will cover equal distance in equal time. This is known as uniform motion. Next is non-uniform motion. That is just opposite of uniform. When an object moving along a straight line path is said to have non-uniform motion if its speed keeps on changing. In uniform motion, speed is constant. In non-uniform motion, speed keeps on changing. And when the speed is changing, object covers unequal distance in equal interval of time. If the object is moving fast, it will cover more distance. If the object is moving slowly, it will cover less distance. So, suppose the time is fixed for 5 seconds and when the object is moving fast, it was covering 10 meter. But now the object is moving slowly, so it will cover less distance. For example, 8 meters is covering. So unequal distance is covered in equal interval of time. Time remains same, but the distance covered changes because the speed of the object is changing. This is non-uniform motion. Speed keeps on changing. It does not remain constant. Example is motion of a train starting from a railway station. When a train starts from railway station, first it moves slowly and gradually its speed keeps on increasing. When the speed increasing slowly, so it is known as non-uniform motion because it does not move at a constant speed. When the train reaches up another platform, its speed again keeps on decreasing. So sometimes speed is increasing and sometimes it is decreasing. It is known as non-uniform motion. Non-uniform motion, another example can be a car which is moving on a busy road. When a car moves on a busy road, the speed of the car keeps on changing. You cannot keep on moving at the constant speed. According to traffic, your speed keeps on changing. So this is another example of non-uniform motion. Non-uniform motion is also called accelerated motion. Accelerated motion is that in which the speed of the object keeps on changing with time, increases or decreases. that keeps on increasing, it is known as accelerated motion. This was all for today's session. We will continue the chapter next time. Till then, understand the topics that I have explained. Thank you.